All right, welcome back for another episode of Disc Golf Physics. This time I want to talk a little bit about impulse and momentum. So, momentum's a word we use kind of in our everyday language, but in physics we have a very specific meaning for what momentum is. It's the mass of an object multiplied by the velocity of the object. So, we use the symbol P. I don't really know why, but P equals m times v. So, this disc has a mass of 156 grams, and if I throw it at a certain speed, it's going to have a velocity in that direction, and I take that mass, the 156 grams, and multiply by whatever the velocity is. Actually, I turn it into kilograms, so it'd be 0.156 kilograms times however fast it's going in that direction. That's its momentum. Momentum is a quantity of motion. It's kind of like if you get hit by a speeding car or a slow-moving truck. Both of them kind of are bad for you, right? Like a big truck doesn't have to be moving as fast to do as much damage because it's got more mass, so it has just as much momentum as maybe a fast-moving car would because it's got less mass, but it's got a higher velocity. So in disc golf, momentum is going to be related to how fast I'm throwing. So the disc weights don't vary they're not extremely variable. So they don't vary very much. 156 grams compared to 175 grams. It's fairly close, but how fast the disc is moving through the air, that can vary a lot. Ultimately, I want to get a lot of momentum on my disc, however massive it is. If it's a heavy disc or a light disc, I still want it to be moving fast when it comes out of my hand. On the other end of things, when it hits the chains, maybe it's going fast, and we want it to slow down and get dropped into the basket. That change in momentum, when it's going from either standing still to moving fast or moving fast to standing still, any change in momentum is called impulse. And impulse equals the force that's applied to change the momentum multiplied by the time over which that occurs. So I want to talk a little bit about how we change impulse and how that plays out in disc golf on both ends, both as it's speeding up and slowing down. So I took a video of myself putting into a Dynamic Discs Veteran basket. I really like the Veteran basket. It's got nice solid chains, heavy chains. So the purpose of those chains, if we watch the video, the chains catch the disc and drop it into the basket. But if we look a little more closely, there we go. All right, so I see the disc coming in, and you'll notice it's moving at a pretty constant rate. Each click of the button advances us one frame. That's 1/30th of a second, and it moves exactly the same distance each time, or at least close. I'd say any variation in that is more due to my clicking ability than the differing velocity of the disc. And that's going to keep going until right here, the 304th frame of the video, when disc meets chains. At that point, the chains impart a force on the disc. The disc had a mass, the disc had a velocity, so the disc has a momentum. Momentum equals mass times velocity. The velocity is going to be reduced because we're applying a force, but that force is applied over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like on the 10th click, we have halted at least most of the forward momentum. We got a little bit more forward momentum, but it's mostly going into twisting the disc. That's actually really interesting that it's twisting like it is. Maybe in a future video, I'm going to take some more putts on different baskets and see how the discs react in the chains. I think that'll be really neat. But that's not what we're talking about today. Today we are talking about a change in momentum. So after 10 clicks, the disc's forward momentum has been halted, and if we watch the rest of the video, it falls down into the basket. So what does that look like? Graphically, we see that in this portion of the video, we're moving at a relatively constant velocity. I'm thinking any of those ups and downs are pretty small, and mostly due to, again, my clicking ability more than any changes in the velocity. Fairly constant velocity, flat line here, until right there. That's the spot. That's the frame when the disc hits the chains. At that exact instant, the chains start imparting a force on the disc, and the disc starts to change its momentum. But it takes place over a period of 10 clicks, I counted, which is, if it's 1/30th of a second per click, that would be 10/30ths of a second, or 1/3 of a second. So in the period of 1/3 of a second, the disc goes from a velocity somewhere in the vicinity of 7 meters per second down to a velocity around 0 meters per second. That's in the X direction. That's the horizontal direction. All right, so a dynamic discs veteran basket has fairly heavy chains. They're somewhat standard to the high quality baskets that are out there. But certain baskets have lighter chains, and you can imagine hitting baskets that have heavier chains. What does that change? So if I change the force, how is that going to affect that change in momentum? Well, let's look at it in its extremes. So at the extreme end, we might have chains that don't move at all, that don't give at all. And we've kind of experienced this. It's the worst sound to hear in disc golf when you hit something that doesn't give, that doesn't allow the disc to change the momentum over an extended period of time. When we hit the band, it's the worst sound. I hate hearing that clunk sound. But for the purposes of science, I videoed it. So now, I hate that sound. But watch. But if we find the frame where the disc is coming into the screen and it's about to hit the basket, it hits the basket, and it's already in the very next frame going in the opposite direction. So not only has it come to a stop, but it has, in fact, accelerated in the negative direction. So in less than 1/30th of a second, so 1/10 the time, it has come to a stop and even moved in the other direction. So we have an even bigger change in momentum, but it's taking place in a much smaller time. So there's a substantially larger force imparted on the disc, which causes it to move backwards. I actually saw this in action over the weekend at the Ice Chains Open we had hosted locally here. And a friend of mine was putting and hit chains that were literally frozen with ice. And they didn't give. There wasn't enough time, because there was no give in the chains, to spread that force out and change the momentum. So instead, there was sufficient amount of force imparted from the chains that spit the disc right back out. On the other extreme, there wouldn't be any chains at all, and that wouldn't change its momentum at all. If there's no chains, there's no force. If there's no force, there's no change in momentum. But what if we have something a little bit less extreme than that? What if we have a practice basket with really light chains? This is a Wham-O basket with additional chains added in the inside. All right, that was too fast. I couldn't really see it. Let's go frame by frame. All right, the disc is in the frame now, and we see it moving in. This putt's going a little faster than, this is actually my friend Dan Smith putting. I was filming, and he putts a little faster than I do, but we can still see that it's regular intervals for each frame. So it's moving at a constant velocity until it hits the chains. Oh, that's cool. Look at the basket actually flexing with the impact force. It's still doing that rotation, which is fascinating. I'm excited to dig into that a little bit more. But what we're seeing is it's still carrying forward. The rotation of the disc does confound this a bit, but the disc itself is continuing to move forward as it passes through these chains, which cannot apply as much force. They're lighter. They don't offer as much resistance. And so the disc moves almost all the way through those chains before coming to a stop and ultimately dropping into the bottom of the basket. With the lighter chains, the amount of time that it takes, it was a whole bunch more clicks for me to get from the beginning impact to the final stopping of the disc. More time equals less force, And this is more on the end of the spectrum where it might actually go through. There might not be enough force to change the momentum enough to actually drop the disc in the basket. One more implication, not on the catching side of things, but on the throwing side of things. I was lucky enough to come across a video of Thomas Gilbert throwing in slow motion, and he gave me permission to look at it in terms of the physics and share it here. So what I did was I aligned it with one of my throws from a similar perspective, and I timed it so that we started our pulling through motion on the throw on the same frame. So we'll see the amount of frames that it takes to complete the throw. Now there's a whole bunch of stuff that I can take from this video. There's a lot of feedback that I can gain by comparing my throw from his. I mean, even right here, you can see his body position is substantially different than my amateur level body position. You can see his right shoulder, his left shoulder position relative to his right. The loading of the hips is different. So there's a lot of good stuff to take from this that I'm hoping to really dig into and improve my own form. But what we're specifically looking for is the amount of time of the throwing motion. So this fairly consistent, except I'm a little bit out in front. So I am taking less time during my throwing motion, which means he's applying his force, which is probably more than what I'm applying, for a longer period, which means he's getting a much bigger change in momentum. If he gets more force and more time in contact, both of those lead to a larger change in momentum. And right there, I am releasing the disc, and he's still got it in the power pocket here. He's still generating power and accelerating the disc forward. He's still applying force to change the momentum of the disc. The disc is no longer in my hand, and it's still in his as he follows through and releases. I think it just emphasizes the importance of the follow through, maximizing the amount of time in contact with the disc. So those are two aspects of impulse, which is change in momentum, that apply directly to disc golf, into the throwing motion and into the catching of the discs by the basket. So I hope that gives you something to think about as you're out there on the course playing. Hope it helps you out. Thanks for watching.